Okay, let's start. So we are going to discuss this particular question today, daily challenge, maximize distance to the closest person. So I will directly discuss the example here. So this is the example given 1 0 0 0 1 0 1, right? And this one denotes the seats which are already occupied by someone, and 0 is the empty one, right? So this is the person who wants to sit in the place so that he can maximize the distance from his nearest person. For example, if he is sitting in this particular position, right? So this particular person is the nearest to this location, right? So the distance is only one. Okay. But if you will sit here, the nearest person is both these two, right? And the distance is two, which is better than the last one. So this will be the answer of this particular problem because the distance is maximized, which is 2. You cannot find other location better than this, right? So you have to solve this problem and in an optimized manner, of course. So I will give you order of n solution for this particular problem. There's some three different solution, but all those solutions are similar. So I will explain one. So for example, here, what we can do, we can create a variable which will maintain the last. So there are three cases which you have to understand first. First case, there are some empty seats, right? Here in the starting. So if the person sit in the first seat, the distance to the nearest person is this, right? Okay. If there are empty seats in the last, then person should sit in the last one, right? Not here, because it will not maximize this distance. So if sitting in the last position, the distance is this one. But if empty seats are in between two seats, right? So which seat is the perfect one? So what you have to do, you have to calculate the distance between these two ones and then divide it by 2, right? Middle one. So that is it. So three cases are there. Either empty seats are in the starting, in the last, or in between. Okay. So what you will do, you will like in this particular case, there are no empty seats in the starting, no empty seats in the last, empty seat only in between. So you will maintain the last one, means last occurrence of one. Okay. So this is the case here. So for example, I'm just removing this all. Okay, again starting the same example. Okay, so this one is occurring. So what you will do, you will store in the previous variable. You will create a variable where you will store the occurrence index of last one. So previous is, in this particular case, is 0, right? So when this one will come, you will store this one in the previous, and then start checking. Your pointer will keep on going, right? When you will um, get the next one, right? This one. So you will check what is the index of previous. It's 0. You will so, and the current index is 1 2 3 4 4, right? So you will subtract from the current index minus previous and then by 2. If this particular value is greater than your global maximum, means you are maintaining somewhere global max, which is your answer, right? What is the maximum possible distance, right? So if this is greater than your global max, you will update your global max, right? And then what you will do after this, you have to keep your pointer moving and store this one to the previous now. So this previous will be updated to 4 and keep the pointer moving. Again, the pointer will come here because 1 is here, right? So the current index is 6. So 6 minus 4 by 2, which is 1, right? And previously it was 2. 4 minus 0 by 2. 4 minus 0 by 2, it was 2. So global max was already 2. Now it's coming 1. So there is no need to update global max because it's not greater than global max, right? So in this particular way, you can solve this problem. If there are some starting zeros also, right, and ending zeros. So what you will do, whenever so you have to just check two more conditions. Whenever you are facing your first um, one, right? In that case, you will check if that first one minus 0, means the location of first one, which is in this case 0, 1, 2, 3, 4. 4 minus 0. If it is greater than your global max, update it. Otherwise, leave it. And then keep going on. And for the last one, you will do the same thing. Previous index you are storing, right? Previous one. So when your array will end, you will just check the total length of array minus previous index. If it is greater than global max, update it and leave it. So this will give you your answer. And this is the solution for this particular problem. I will show you my solution just in brief. And I think you should code it yourself to understand it better. So this is my solution. I maintained a maximum, which is global maximum. And last one, the previous, right? I just named it last. And doing the same thing. If I'm finding any seed which is 1, I'm checking 2 conditions. If last is, so I initialize it -1. So I'm in this particular case, I'm checking the initial zeros, right? If this is the case, some zeros are here, right? So if I means current I, this one is greater than max, I'm updating it. Else, if we already have something in previous variable, right? Means in last variable, then then case is this one, when 2 ones are there and nothing is, when zeros are in between. So this is the case, then I will do I minus last by 2 is greater than max, and same thing checking. And after the full array iteration, I will check that this particular condition when there are zeros appends in the last of the array, right? This particular condition, and returning the max. So this is the solution for this particular problem. Thank you for watching, and see you soon.